Meetup chapter from Cleveland. I've been working with MuleSoft in the last 4.5 years, but I've been in the software design and engineering and for a period of 18 years now. So it's a long way of experience, but I caught up with MuleSoft a few years back, and then it's pretty good ride with that. So yeah, and then we have Flavio from Redis, and then Bruno from Salesforce. We also have Tintu from Salesforce, who is the co-host with us on this. So a warm welcome to you all, having for all the ones who are attending this meetup. Let's hand it over to Flavio. Flavio, go ahead.
Thank you. I'm Flavio from Redis. Can you guys see me all right?
Yes.
Okay, thank you. So yeah, let's get started. Why are we here, right? Well, there are a couple of slides here from the meetups. I don't know if you guys want to cover those. They're just
Yeah.
the
So
standard.
yeah, it's a standard safe harbor statement saying the speakers and the hosts are organizing this meetup in their individual capacity. It's nothing, no promotions or anything from the MuleSoft, so we are not really representing anything. It's just a common interest among all the muleys. So, and then this presentation is strictly for the learning purposes only. Organizers and presenters do not hold any responsibility that the same solution will work for your business requirements as well, because you have to do your due diligence on all the use cases you handle and take it all what you learn from here to apply on your use cases. So that's basically what we are trying to do. And this presentation is not meant for any promotional activities. So, yeah.
Very good. Thank you. So let's get started. Why are we here, right? Um, we're here to talk about Redis and MuleSoft, the integration. And Redis is a fairly, um, a very popular database. And many people, many developers in particular, use Redis. And the question here is why? Well, it's very simple. Users want real time. And typically your application stack has only 100 milliseconds to respond to user actions, right? So where do you spend those 100 milliseconds? If you spend that in a uh, backend and in the database, if you use a DBMS, typically you're going to get with volume, say 40 or 50 or 60 milliseconds in the database. Well, if you spend that time there, you only have another 40 or 50 milliseconds for the whole stack, right? For the application or for the network to respond. So a much better way is to use a really fast database, which is Redis, that responds under load in less than 1 millisecond. So basically our gold standard is less than a millisecond latency. And for a load that is typically 25,000 ops per second. How does Redis do that? A few reasons. It is an in-memory database. It is a key value store, right? Much faster. And it has several native data structures that help that capability come to fruition. So Redis is used mostly as a cache, and most people know the very popular cache pattern that's called cache aside. We're using cache aside in this demo here today, but know that there are several other patterns, and the other patterns are used for other types of use cases, right? So we're just scratching the surface here. Now, what else does Redis have to offer, right? Well, Redis is a real-time data platform. And basically, it is built on top of OSS, of an open source core, right? And it has several data structures, native data structures that support several different types of use cases. And then it also has additional data types and structures, like, for example, native JSON. It supports vector structures for people who are using AI, especially large language models today. time series and probabilistic filters. So very rich ecosystem. It supports a lot of the uh, 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 tools that developers need. So the developer experience is really enriched. Lots of support for clients, different clients, of course, and a desktop GUI called Redis Insight that you can download and check. It's really cool, really interesting. Uh, in addition to that, data processing engines, and this basically adds to the capabilities. You can ingest data from other platforms into Redis, and you can get data from Redis into other platforms, right? Connectors. And in this demo, it's one example in which we're interacting with MuleSoft. And several other capabilities, querying and searching. For example, you can search JSON and hashes, which is one of the data types that we're using here. We're using hashes in this demo. And naturally, enterprise-grade capabilities. You have active-active, durability, auto-tiering, multi-tenancy, right? And security. So just a quick view of what the Redis Enterprise brings to you. So speaking of the data structures, this is just a quick view of some of the most common data structures in Redis. And this what's highlighted here is the hashes. It's like a dictionary. It's the one that we used in this demo, right? Other data types. Strings are used for caching normally. And hashes, which we're using here, are normally used for user sessions and user profiles. Then you have lists that support queues. Customers usually start with queues and then they graduate after once their queues become more complex. They graduate to streams. Streams has a built-in timestamp in it, so you can do all sorts of windowing and aggregations in a very easy way. And several other types. So, for example, we have sets, sorted sets. Sorted sets are used in leaderboards for the majority of the top gaming organizations in the world. And that's why the gamers, the players, can play in real time and get responses in very, very fast responses. So that's just a quick overview of what the data structures are. You see there's a wide variety. Some of them are more sophisticated, and they support different types of use cases. So let's look at, as I mentioned, this hash data type was used in our demo. Let's take a quick look at the demo structure. Basically, what we built, Bruno and I, was um, e-commerce application. So basically, we simulated an e-commerce application that hits the MuleSoft platform. And MuleSoft uses two backends, right? It checks for the data, if the data is in Redis first. If the data is in Redis, just gets it. If not, it goes to the other backend platform, which is, in this case, it's MySQL. And MuleSoft has, of course, many great capabilities. And one of them is that it has a connector for Redis, and that's what we used, right? So let's see how we did that. Like for the schema for the backend, for the DBMS, is very simple. We had a customer table and a product table, and we loaded 2,000 customers and 500 products. Very simple. So how can we actually map now data from a DBMS schema, like from MySQL, right, to Redis, right? It's actually very easy. You'll see here, you have here customer table, and in this case, we loaded 1,000 out of this data here that we have in the table. We put 1,000 in Redis, and we left the other 1,000 out of Redis, just on purpose, so to actually force it to go to the other customers that were not in Redis, right? Just for demo purposes. So here you can see how the mapping is actually done, right? You have the, let's take a look at customer, for example, number 2 here. You have a customer ID, and you have recommended products that day for that particular customer. So this customer has those three products recommended for him, Mr. Carr, right? So basically, the way this is done, you can see here, we have two data structures in Redis, which are represented in red here, and those are hashes. So this is the customer recommendation hash, and this is the customer tier hash. And depending on the tier, the discount is different. That's basically how this e-commerce platform works, and it's a common setup for many e-commerce platforms. So you can see how the tier first here, right? Because tier one, customer ID two, tier one, and you see how we have customer two, tier one. It's a simple lookup that is done now in this hash, right? And then we have the recommendations, and the recommendations are done in this particular manner, right? We have for this customer, those are the recommendations, 103, 225, 153, directly from here. So very simple, right? So let's look now at the uh, product prices, right? How does that work? It's a similar manner, right? We have the products here. So for this particular customer here, customer ID one, for example, right? You can see that this particular customer is from tier two, and we built three hashes basically. We have the regular one. This hash here, cost price one, is the unit price that they normally pay. Everyone pays that price, right? So for um, so this customer in this case, customer one, for this product 93, the price is $42. Okay. But because this customer is from tier two, right, belongs to tier two, we have those two hashes, right? One hash for tier one hash for tier two. So customer one, product 93, he has a discount, $37.8 in this particular day. So that was loaded into Redis. And therefore, if the customer decides, when the customer logs in, that discount shows up immediately in the front end. So basically, that's how it works. And you can see it's actually very simple, right? This mapping. So how do we get the data now, right? That's next on SQL. Everyone knows how you make the calls, right? You do a select here. So basically, when the customer logs in, their ID is used to get the price tier and product recommendations. And once we know what the tier is, right, and those particular products that we're looking at, the recommended products, we can actually do another query and pull the particular tier price for that particular tier. In this case, it's this customer is from tier two, so those are the prices here, 64.8, etc. So using the product recommendations, get the appropriate prices, right? How do we do that now in Redis? It's the same flow. Customer logs in, use their ID to get their price tier and recommendations. So this is the command in Redis, hash and then go to that particular uh, table, and then customer one, it's tier two. And then go to the recommendation table, right? For customer one, the recommended products are these. Now, using the product recommendations for that tier, get the appropriate prices for the recommended product. So again, we go to the appropriate hash get, go to the appropriate key, and then enter uh, the key value that we're looking for, right? So customer one, product 93, the price is 37.8. Same thing for the others. This is one way to do it. Another way to do it is to use other commands that Redis has. In this case, we're using the hash multiple get, HMGet. So I can pull several. We can pull thousands at once, right? If you have them. So it's like a dictionary, as I mentioned, and it works really well. So basically, this is how it works. Let me make a quick pause here and ask you if there are any questions so far. Very good. So I wanted also to to share a very quick demo that shows how fast Redis actually is, right? So basically what I'm doing here is I'm going to the one database in the cloud, and I have the same database size that is used for the demo. This is the database MuleSoft for the demo. This is the benchmark that I use just to do this particular demo here. And I'm here looking at the console. Nothing's happening in the database. So the database is basically, there are no ops per second. As you can see, there's no, and the latency, of course, there's nothing happening, right? So what happens if we um, put a load in the database? So I have this load ready to go here, and I'm going to push the load into the database. So I'm simulating a load that will take place. Let me try to put them in the same screen. So here, what's happening is I'm pushing uh, a lot of data. I'm simulating 100 connections, and I'm putting a lot of keys and doing lots of reads as well. As you can see, we're beginning to see some action here. So you see that we're pushing, let's see here, we're pushing 40,000 ops per second right here, 40.1. And we see that the latency is less than 0.18 milliseconds right here. Now it went up a little bit to 0.22 milliseconds. It's still under 1 millisecond, right? So let's see how this will behave. Still less than 0.22 milliseconds. So this will be done very quickly. There it is, it's finished. The run finished, so no more load. Latency goes back to 0, right? So the latency went to 0.22 milliseconds. I hope this is it large enough to see the screen, to see the units?
Yeah, it's better now.
Okay, so you see that in the last 5 minutes here, we went from, this is 45, this is 40,000 ops per second, and the latency was 0.22 milliseconds. So and then you see that this latency, right? So why if I go back here and the benchmark finished, right? And we are seeing here, oh, why is the average latency 62 milliseconds? Well, this is the round trip because I'm pushing. I'm not in the same cloud. I'm using GCP here. You can see and then the database itself is on AWS. So that's the round trip between one cloud and the other, right? That you're seeing. But if you have the workloads in the same cloud, right, the components in the same cloud, you're going to see this response. This is the response that you're going to see: 0.22 milliseconds from the database side. So we put in this case this dashboard shows us several other metrics here, but you can see the reads, the writes, and then you can see the number of keys. In this case, we put 4,000 keys in this short interval, right, in the database. So as you can see, it is really fast, and it supports workloads. Like even though this is a workload of this workload is fairly simple, but you can have more complex workloads. And our standard is that for our typical shard, we support 25,000 ops per second at less than 1 millisecond, right? But it's a conservative it's a conservative number. Customers have been known to push more complex workloads and still get less than 1 millisecond of latency. So I hope this gives you an idea, right, of how effective and how fast Redis is. Let me pass on now to Bruno, so Bruno can actually talk about the MuleSoft part of the demo. Take it away, Bruno.
Yeah, thank you, Flavio. And hi, everyone. My name is Bruno Neves. I'm a solution engineer here with MuleSoft. I've been working with integration platforms for at least the past decade. I've worked with multiple vendors, and I've been with Salesforce, MuleSoft for about a couple of years now. Good to meet you all. I'm based out of Florida, originally from Brazil. So I saw attendees from Brazil and from Florida. So that's nice. And hi to everyone else. Good to have you all. I'm going with the assumption that most of the people here are familiar with MuleSoft. After all, it's a MuleSoft meetup. So I don't have a lot of slides talking about MuleSoft or introducing MuleSoft because, that same assumption. But essentially, we are today leveraging the integration component of the platform. So what we really built here is that application that Flavio was simulating. So it's MuleSoft in the mix, right, in between the systems of engagement, which is the e-commerce application, and the systems of records, whether it's going to be Redis as a side cache or the actual database, the actual systems of record. And depending on the situation, we might be going to Redis. Depending on the use case, the scenario here, we might be going to the database, which is in this case being represented by MySQL. As Flavio mentioned, for our demo, we established that the first 1,000 users, meaning user ID from 1 to 1,000, are going to be going to Redis, while users ID 1,001 through 2,000 are going all the way to MySQL. So I'll be explaining to you how the flow was designed to accomplish this use case, and try to get into the more detailed decisions that were made here to make it all possible. So the first thing we are doing here, I've deployed this flow, this MuleSoft flow, to the same cloud region where everything else is running, where MySQL and Redis is also running to minimize that network latency. So as you can see, I've deployed it to Cloud Hub 2.0 on the top. So the very first thing we're doing, we are invoking this flow, right? So we're doing a get against the product list API, and the user ID is user number 1, right? So we have user number 1. The very first thing we're going to do here is do a get from hash straight to Redis to make sure whether that ID is present or not in the cache. And depending on the result, it will go one way or the other. So in this case, it was a hit, right? So it means it was able to find that user ID with that first get customer tier action, and it went to the hit, which is the default route for Redis. So I'm setting the first variable here, which is essentially describing that this user ID belongs to price tier number 2, right? And depending on that price tier, I can then go get what are the product recommendations for that specific customer on that day, like based on all previous navigation data on the site. What are the most what are the recommended products this customer might have most interest in? So we were able to retrieve 3 products, products 93, product number 10, and product 56. We once again have another set variable action to put all those products on the variable so that I can make a third call to Redis to retrieve what's the specific price for that specific product on that specific tier, okay? Before I send it all over back to the e-commerce platform. So I got the prices now with the third call, and this is a for each call, right? So for each product recommendation, I'm retrieving the right price on the right tier. I set the prices in a variable once again. And finally, I transform the message to the format that the e-commerce platform is expecting. So I got the 3 recommendations. Here you go, e-commerce website. You can now show it to the customer. Now, the second possible scenario here is when the user ID is not yet loaded on the cache, right? So in this case, it has to go all the way to the database, to the MySQL database. So I'm now using user ID 1001, calling the same API, right? So it's one implementation for both scenarios, as you can see. It goes to the database, it retrieves the customer price tier and recommendation. So this can happen in a single call, given the way the database schema was set up. I place everything in a variable, and then I make a second call to get the price per product recommendation. So now on the second call to the database, I have the price for that specific tier. I finally format the response to the same format that the e-commerce platform is expecting. So the e-commerce platform doesn't really even know whether we are getting the results out of Redis or we are going to the database. You would only know if you looked into the latency, right? Because depending on which way it goes, they would notice a different, the response time is going to be different in one way versus the other. So to test this, I'm using a performance testing tool, and I'm simulating only 5 virtual users for 1 minute. And in this case, I am specifying that I only want to test the MySQL side of the flow. So by running this test for 1 minute for the MySQL path, we were able to assess 276 total requests processed with an average of 4 requests per second and the average response time of 114 milliseconds, which is once again above that 100 millisecond threshold that Flavio mentioned to give that the impression that the services, the applications are responding in real time. Anything above 100 milliseconds from the human perception perspective, it doesn't feel like a real-time call anymore. It starts to feel like, there is a delay here. The second test we ran, again, using IDs from 1 to 1,000 to force the flow to always go to the Redis side. Same number of virtual users, same number, same amount of time, 1 minute. We were able to assess a slightly improvement in performance in terms of the total number of requests that were sent or processed, right? We saw that we were able to achieve a little over than 4 requests per second. However, what's really important to notice here, and that's where most of the difference will be, is at the average response time. So we were able to bring down from 115 milliseconds to 75 milliseconds, which is under that human perception that, okay, this is now real time because it's under 100 milliseconds for every call for that product recommendation to return from the server. Now, this is the side-by-side comparison. And again, just emphasizing that difference from 114 to 75. But the most impressive thing here is really when you go to Visualizer and you start looking into the internal traffic, right, from the MuleSoft application that you see here to either Redis database versus the MySQL database. And as you can see, whenever it goes to Redis, we are only looking at 1 millisecond. And this is including network time, okay? Because everything is running in the same data center or in the same region, we are able to get responses from Redis at 1 millisecond, maybe less, right? Maybe 1 millisecond here is the minimum we can show in Visualizer. But whenever we go to the database, what we assessed is that it takes between 15 to 20 times more the time it would take to go to Redis. Okay, so that's a big difference. And as the volume increases, that difference becomes even more noticeable. So for the demo today, I can show you that performance testing running in real time. And then I can do that before we jump into what are the conclusions we were able to assess with all the tests that we ran, and by building this application, this Mule application, what were the lessons learned that we can share with the community. So if you ever have to go through a similar project, or at least you know you're not really starting from scratch, you have some knowledge that you are acquiring today from this session. All right, so let me bring up my performance testing client. So I have configured some dynamic variables here to retrieve random user IDs from 1 to 1,000, and then from 1,001 to 2,000. And again, that will determine in which way the flow is going, Redis or MySQL. So the first test I want to run is against the MySQL server. So I will disable the first request and go with only the second one that I know is going to leverage the variable that goes from 1,000 to 2,000. Again, the same 5 users and a minute of duration. So when I hit run here, it is essentially running locally, right? So this is running from my laptop, and again, I am in Florida, but everything else is running in Cloud Hub US East region, along with MySQL and Redis. And here from Florida, the total average response time, you can see here, right? So it's a variable. It's varying from maybe 110, 120 milliseconds. The screenshot I had in the deck, it showed 114. So I think we are seeing similar behavior right now. And again, this call includes MuleSoft processing, network latency from Florida to Virginia, and a couple calls. So one call to Redis for that hit or miss to make sure the user ID data is in Redis or not. And if it's not, it's going to make an additional 2 calls to the MySQL database. So everything is included in this average 110 milliseconds. So this time it performed a little better, but still over that 100 milliseconds a human perception of what's real time, what's not. So very consistent with what we had captured in the slides. Now I'm going to run again, but this time I will force the flow to always go to the Redis database. So I'll disable my SQL, same amount of users, same amount of time. I'll initiate the test. Now, here there is a difference. It's still going to that same API, right? That same Mule application. It's making that common Redis call to determine if the user is or is not part of the Redis database. And if it is, then it's going to make 4 more calls to get all the product recommendations. Remember, 1, to get all the product recommendations for that specific user ID, plus the price tier. And then for each of the product recommendations, remember there was that for loop. So we were doing another 3 calls to Redis. So in total, it is making 2 additional calls to the database. And even so, were able to assess a 74 milliseconds average response time with a minimum of 54, which is really low considering the fact that we are calling Redis more times than we are calling MySQL database here. So again, that's really impressive. If I go back to my browser, hold on. Wait, how do I go back here? One sec. I want to show Visualizer. And I lost my window. Yeah, it is. Okay, so let me do a refresh on Visualizer. And the same is true, right? Remains true. So we are still seeing 1 millisecond average response time from Redis and 20 milliseconds when we go to the database.
And I have the actual response from the Redis side if you wanted me to show, Bruno.
Yeah, that'll be great. Let me stop sharing. There you go.
Sure. So here, let me get, this is what you pushed, right? And then here we have about 0.08 milliseconds, and the top was, let me push this a little higher here. Yeah, it was less than 0.08 milliseconds, the top, right? Between 0.06 or to 0.08. So that was the only load that showed here. And this is the MuleSoft database, right? I had done the test in the benchmark that we saw earlier, right? But now Bruno is using the MuleSoft itself. So you see the metrics here. 5 minutes, there it is. Less than, again, 0.08 milliseconds. 0.07 actually is showing here as the top. So yeah, it's very performant.
Yeah.
So let me send it back to you.
Okay. So I'll go back to presentation mode. Okay, here you go. And now going to what we were able to, let me go presentation mode. There you go. What we observed during this practice that, well, it was really easy to integrate with Redis, right? Because there is a MuleSoft Redis connector available in Exchange today. However, remember Flavio mentioned that hash multiple get command that is supported by, um, can I say, framework or libraries, client libraries, that is yet not present in the connector, in the Redis connector. And that explains why I had that for loop to make the individual hash get calls to Redis. If the hash multiple get was present, then that loop would be eliminated, and I could make just a single call to Redis, which once again would accelerate that application even more. But that's just not the current state of the connector today. Um, so that's a lesson learned. Um, uh, Also, I'm sure you are aware, MuleSoft has an object store, and depending on the use case, it may make sense to just leverage this object store that is included with the base subscription. But there are a couple things to notice, right? So first, there is a limit of a transactions per second limit per application that's there by default, right? Which is 10. So if your application is receiving volumes that are over 10 transactions per second, you might be looking into um, upgrading that part of the subscription, the Object Store subscription, to the premium one, which is going to allow for up to 100 transactions per second. And that's the high limit you can reach. Even if you add more uh, uh, more of this add-on, will never be able to provide you with more than 100 transactions per second. So that's the limit. Uh, and if you're under that limit, you're fine. If you're over that limit, you might be looking into analyzing what Redis can do for you. In terms of values that we would support uh, in that dictionary, for the not the key, but for the value itself, will be 10 megabytes. So again, if you're under that, object storage may be for you. Lastly, there is this other limit of 100 million API requests a month per subscription pack. So that limit can also be increased as you add more subscription, more of the MuleSoft Object Store subscription package to your subscription. So if you ever are hitting that limit, just know that you can increase that limit by upgrading your subscription. So I think in general, what I'm trying to say here is that the object store is a common solution for MuleSoft only projects, while Redis would be the recommendation if you need that cache mechanism or that performance in-memory database mechanism for things that go beyond MuleSoft projects. Okay, and of course, even though we have these lessons learned and recommendations, it's really going to your decision. The decision that needs to be made here is going to go. It's going to be different for each project. So but make sure to consider what are the volumes and whether the enterprise there is an enterprise strategy to use an enterprise grade um, uh, in-memory database or caching mechanism, and that's going to guide your decision for your projects. I think Flavio wanted to talk a little more from the Redis perspective. What are the recommendations?
Yeah, thanks, Bruno. One thing that customers also notice in is that once you put a cache in front of your backend, everything works better. And why is that? It's because you imagine you have a backend where you have some commonly used data, and that is hitting the database constantly, right? So the database is training under that load. Once you remove that and let Redis handle that commonly used data in the cache, the database gets unloaded, right? Your backend gets unloaded, and then other requests that were not in cache also start uh, moving faster. So the whole application works better, not just because of the cache, right? It's because of that unloading of the backend that took place as well. So the frequently used data are immediately uh, responded to the application because of Redis, and then the not so common requests also become accelerated, right? So that's another side benefit of putting a cache, right? And in terms of scaling, Redis has the ability to scale up, right? You increase the size of the database in the same node, or you can spread, we call it sharding, parallelization, right? We spread the database across multiple nodes. And Redis Enterprise is engineering in such a way that each node has enough RAM and enough cores, right, for the processing, and also uh, basically has enough resources to support that golden ratio that we mentioned, 25,000 ops per second for 25 gigabytes of data, right? So, and you can scale that horizontally. We have seen databases over 10 terabytes in gaming, for example, and that's all RAM, and they perform under average of 1 millisecond. So it's very it's basically easy to scale. So it's the basic idea here, like one key takeaway is that you can get the best of both worlds, right? You have an application, great application like MuleSoft. You can make the whole application that is using it perform better, so that the application itself concentrates on what it does best and doesn't have to worry about, right, the very heavy traffic. Like outsource that to Redis, and the whole system works in a much better way. So basically, those are the key takeaways that we wanted to share with you guys.
Yep. Thank you so much, Flavio and Bruno, for the detailed session on Redis calls, and that was a neat demo on showing how Redis and MuleSoft integrate with showing the average response times. That was very neat. And we had few questions coming in, and it looks like the answers have been provided as well.
Yeah, there's another question from Uresh on
Mhm.
how much the Red's performance vary with huge volumes of records cached. Yeah, so by scaling out, right, you basically can put any type of workload under 1 millisecond. So there are two things there. One is the amount of data that, of course, the more data you have to go through to search and to retrieve, then uh, the naturally the less respond the higher latency is expected. So what you do is as you reach say 25 gigabytes, you just scale out, or in the case of the cloud, we scale that out for you, right? So by scaling out, the resources on the other cluster, on the other shard, will be available to you. So you continue to expect on average 1 millisecond response time, right? With more data. There's another side of the equation, which is ops per second. So in applications that are very heavy on ops per second, and that's the typical case for microservices, the ops per second also have to be taken care of. So there we have some customers that have hundreds of thousands of users, and sometimes a lot of those users are there banging on the front end. In that case, because the ops per second they can go to 1 million ops per second easily for an application. In that case, you also have to uh, spread out the database into different nodes and shards, so that even if you don't have a lot of data per se, that spreading out guarantees that the ops per second will be served by each of the nodes, according to the resources in each node. So those are basically the two rules, right?
So, yeah,
Go
please go
ahead.
ahead. No, please go ahead.
Yeah, so no, that was basically the other side. You take care of the data size, the
Mhm.
growth of data, and the growth of ops per second. And the response, the answer to both of them is scaling out.
So, is Redis available only on cloud, or do we have an on-premise sub?
No, if you go to the previous slide, actually, that's a good question. It's available on cloud, or in all three clouds, right? And it's also available on-prem as a software, right?
Yeah.
And then you can actually do that on bare metal or on VMs, and then you
Mhm.
can do that in Kubernetes, install in Kubernetes. Several flavors of Kubernetes,
Yeah.
including
So, with
OpenShift. Yeah,
the reason I asked, I didn't observe this slide because if enterprises have issues having their data on the cloud, they can still use the on-prem, and the access to on-prem would be even faster than accessing things on the cloud. So,
absolutely. And
just to
also,
remember
yeah,
that.
no, thanks for the question. And in the cloud also, we have both. We have software that you can install yourself on your VMs, on your Kubernetes service, right, in the cloud, or we also have a fully managed offer in all three clouds, right? Basically, you basically buy it as a service. We manage it for you, scale that for you, maintain, upgrade that, do everything. So it's very flexible. And some customers actually have a hybrid deployment, meaning they start on-prem, and then they have another leg of one database in the cloud, so that they can have active on-prem and in the cloud
Mhm.
for high availability and also disaster recovery reasons.
Yeah. One more quick one. So, is there a default invalidate cache? I mean, invalidate timeout period on this, or do we need to handle it as a part of the use case that if the backend database got updated in the meantime while the cache is being used, is there a way that Redis can smartly identify the database changes and update the cache in the background, or is it something that we have to handle it like as a part of the use case?
Okay, I'm sorry. I think you touched on a couple of points there. Uh,
Okay.
One is the time to live, right? For the
Yeah.
cache, the
TTL.
validating TTL, the
Mhm.
invalidation. Yeah, that's completely configurable, right? You
Okay.
configure that at the database level or at the key level, right? Both, right? You have those options. So you have full flexibility there. Yeah.
Okay.
So and the other part, I'm sorry, you also had another.
So the other part is, let's say we are already using the Redis cache and there are entries in the cache that are being used by the application.
Mhm.
And in the backend, in the MySQL database, in the use case that we have seen, let's say some data got updated, like some products price has changed
Yep.
during the time of the day, and if it doesn't reflect in the cache, then it will give a
Yep.
different picture to the user. But from a numbers perspective, like a finance budgeting perspective, inventory perspective, it's a different story
Yep.
on the company side. So if there is a thing like that, is Redis having any services in the background which will automatically identify the database changes and update the cache, or should that be handled as a part of the use case that, okay, hey, if the data is being updated in the database, like the MySQL in this use case, the
Yes.
flow has to handle that, to update the cache, like invalidate the entry and
Yeah.
re-update.
Great question. And that is a key difference between when you have cache aside, right, and then other patterns. In this
Mhm.
particular pattern that is described, right, if the value changes in the back end and you need the value to immediately propagate to the cache, right, Redis, we do change data capture to the database, right? That is true for the majority of the database, DB2 included. I see one question here on DB2, right? The majority of we have the connector, and we actually have a separate component that's called Redis Data Integration, RDI, and that basically is configurable in a way that you basically you install and configure it, and all you do is all driven by YAML files. So you don't have to do a lot. You define which tables you're going to watch, which columns, right, in the DBMS. And then once the data changes there, there's a batch. There are two modes, right? The batch and then the regular mode. And once there's a batch in synchronization, first get the data from those tables or from those columns, push that into cache. Once the data changes in the source database, then that gets propagated into cache. So that's another caching pattern different from cache aside that we discussed. Yeah.
Thank you, Flavio. We have a couple more questions in the chat. One from Morley. Uh, is there a performance difference between cloud and on-prem versions?
Not really. It's the same software, right? In the cloud, um, it's we are always because we have deep expertise, right? We're always maintaining it, always optimizing, right? So large customers typically have more expertise and they're able to do that themselves. So smaller customers, we help them naturally, right? It's part of our services. So, but there, it's the same software running on both.
We have another one from Daniel. Can you talk about how Redis sync with the DB when the data is updated? Yeah, I think it's pretty similar to what you have explained earlier.
Correct. And there are a couple of other caching patterns also, right? That I described the CDC, change data capture, right? And we also have patterns in which you let Redis do the update when the application is doing the updates in the front end. The updates are being grabbed by Redis, using Redis as a front end database in this case, right? You can push those updates actually using right behind into the database, right? That is the case when sometimes you have too many updates and the database cannot handle them, uh, especially when you're doing that synchronously. So you can send that to Redis. Redis puts that in a queue and it sends those updates to the backend. And the back lets the backend absorb when it can, right? So it saves it in the queue until the backend is able to update.
So one thing I wanted to add there is that I think RDI would work great when the data is being monitored in a regular database. So Flavio mentioned DB2 and other traditional RDBMS databases. But there could be other situations where perhaps the data is coming from Salesforce, right? And then MuleSoft leverage a Salesforce connector monitoring for new data or change data on Salesforce could also orchestrate that synchronization call to Redis as well.
Yes,
Thank
that's
you, Flavio Bruno, on that. We have one more from Thomas Zunak. Can Redis help in existing solutions where non-Redis DB is used? For example, integration is configured with MySQL DB only. Can Redis be added to the solution to improve performance by caching the results coming from SQL, MySQL?
yes, absolutely. One, this is actually this happens quite a bit with customers that have monoliths, right? We have many applications, and they all depend on one single backend, right? Could be MySQL, for example. So in that case, you want to, it's a monolith, and you want to increase performance, you want to grow, and you start slowly migrating to microservices, right? So it's a very common scenario for us. So we start identifying parts of the application that you can migrate first, and then you transform into microservices and you test, and then you start serving them out of Redis. There are different ways to do that. You can use Redis in this case as a cache aside, or you can even use Redis as a database in that case. So we see customers doing that all the time, slowly migrating those the workloads from MySQL, right, into Redis. And then once they migrate, right, once you move into that new architecture, there's quite a bit of flexibility. And as each of those services grow, you only grow the part of the database that you need, right? So basically, you can scale out in that way. But Thomas, let me know if you have any other any specific questions about your about this field.
Yeah.
Yeah,
Yeah. Anything else to add? We are at the top of
yeah. I
the
think
hour.
yeah. Since Thomas mentioned uh, integration in his question, right? I was wondering if today the application is talking with the database, but there is an integration component in between, like MuleSoft, right? So if MuleSoft is configured to access data in the database, well, then all of a sudden you can start implementing something similar to what we described today, right? You keep the way to the database when the data, where your systems of record is your your source of truth really is. But in parallel to that, you can add those additional logics to verify if the data is already present in Redis. And so you can not only configure a cache hit or miss, but in the case of a miss, after you retrieve the data from the database, from MySQL database, you could have other additional Redis calls that are going to essentially add the data that was missing in the cache now in Redis. So the next time a similar call comes in, you're going to get a hit instead of a miss.
Makes sense. Makes sense.
Yeah.
Yeah. So we are at the top of the hour. Yeah, we have great questions from the audience and everyone, and we have a great presentation as well from Bruno and Flavio. Thank you very much. And for any further questions, we would ask the participants to send them offline, and then we'll be able to get them back, answer that, answer for you. So yeah, thanks, and it's a great presentation. Thank you, everyone, and we'll hope to meet sometime again.
Thanks a lot,
Thank you,
guys.
everyone.
Appreciate it.
Thank you
Thank
all.
you.
Yeah, bye bye.
Bye bye.